For billions of years, Earth's oceans have been vast reservoirs of salt water, defining our planet and nurturing an incredible diversity of life. But what if this fundamental characteristic were to change? What if, in an instant, our planet's immense oceans turned entirely freshwater? This isn't a whimsical thought experiment, it's a stark exploration into the delicate balance that sustains life. Such a transformation would not only redefine our blue planet visually, but it would unleash a cascade of catastrophic events, fundamentally altering marine ecosystems, global climate patterns, and the very foundations of human civilization and our food supply. The immediate consequence of such a shift would be a catastrophic mass extinction event in the oceans. Marine species have evolved over eons to thrive in specific salinity levels, a process known as osmoregulation. Their cells are finely tuned to balance salt concentrations with their surroundings. If the oceans turned freshwater, marine life would suffer immediate osmotic shock. Their cells, designed to expel excess salt, would rapidly absorb water, swelling uncontrollably and bursting. It's a biological impossibility for 97% of marine species, which are strictly saltwater organisms, to survive this drastic environmental shift, leading to an almost complete collapse of ocean biodiversity. With the overwhelming majority of saltwater species unable to survive, the intricate marine food web would unravel entirely. From the smallest plankton to the largest whales, every link in this complex chain would break. Predator-prey relationships would cease, and the vital cycling of nutrients would halt. This isn't merely the loss of individual species, it's the eradication of an entire biome, erasing billions of years of evolution. The once bustling underwater world would become eerily silent, a vast, lifeless freshwater expanse, devoid of the vibrant ecosystems that once sustained it. Beyond marine life, the salinity of the oceans plays a crucial role in regulating Earth's climate through a process called thermohaline circulation. This global conveyor belt is driven by differences in water density, which are largely determined by temperature and salinity. Salty, cold water is denser and sinks, particularly in polar regions, initiating deep ocean currents that distribute heat globally. If the oceans turned freshwater, this fundamental mechanism would cease. Freshwater is less dense and would not sink in the same way, effectively shutting down the planet's vast oceanic heat distribution system, leading to profound and immediate climate disruption. The collapse of thermohaline circulation would plunge our planet into a chaotic climatic state. Without the ocean's ability to redistribute heat from the equator to the poles, extreme weather events would escalate dramatically. Regions currently warmed by ocean currents, like Western Europe, would experience unprecedented cold, potentially leading to new ice ages. Conversely, equatorial regions could face unbearable heat waves, exacerbating droughts and wildfires. This radical shift in global heat distribution would disrupt atmospheric patterns, creating more intense storms, unpredictable monsoons, and widespread environmental instability, making many parts of the world uninhabitable for both humans and agriculture. As if marine collapse and climate chaos weren't enough, an invisible, yet existential threat would emerge: an oxygen crisis. Phytoplankton, microscopic marine organisms, are the unsung heroes of our planet, producing an astonishing 50 to 80% of Earth's oxygen through photosynthesis. These vital organisms are exquisitely sensitive to salinity changes. Their demise in a freshwater ocean would drastically reduce the planet's oxygen production, impacting every breath we take. This shift could lead to severe atmospheric consequences, making the air thinner and less breathable for land-based life, including humans. A freshwater ocean would literally choke the life out of our planet. The ripple effects of marine collapse would devastate human food systems globally. Seafood isn't just a luxury, it's a critical component of diets worldwide. It provides 17% of the animal protein consumed globally, and for nearly 3 billion people, seafood is a primary, irreplaceable source of protein. The complete cessation of fisheries would lead to an unprecedented global food crisis. This protein deficit, combined with agricultural disruptions caused by extreme climate changes, would push billions into severe malnutrition and starvation. The ability to feed ourselves would become one of humanity's most immediate and dire challenges. The collapse of the oceans would not only starve us but also dismantle economies and destabilize societies. The fishing industry, which employs millions worldwide, would vanish overnight, leading to massive job losses and widespread poverty in coastal communities. Food insecurity would fuel social unrest, mass migrations, and potentially international conflicts over dwindling resources. The economic cost would be incalculable, as entire industries dependent on the oceans, from tourism to shipping, would face insurmountable challenges or disappear. This isn't just an environmental disaster, it's a total societal breakdown, forcing humanity to confront an existence radically different from anything we've ever known. The scenario of Earth's oceans turning freshwater paints a chilling picture of an apocalyptic future. It underscores the profound interconnectedness of our planet's systems, from the tiniest cell in a marine organism to the global climate patterns and the sustenance of billions of human lives. This thought experiment serves as a powerful reminder of how finely balanced our world is, and how crucial the ocean's fundamental properties are to every aspect of life on Earth. The oceans are not merely bodies of water, they are the heart and lungs of our planet, and their health is inextricably linked to our own survival.